And hello everyone. Okay, good, mic's working. Hello everyone, welcome back. So in the last video we tried to accelerate the solving of this Spallet Armorous pimple foam. This was the result. You see that the pimple iterations go into the 200 plus. So there's something that's not converging. And if you take a look at the initial residual and initial residuals, it will hover around 0.2 to 0.4. If not it'll go down and then you'll go up and you'll go down and you'll go up. Okay, these things, when the initial residuals go up and down, it is pretty characteristic that the relaxation factor is too small. Yeah, I mean too big. It's too over relaxed. You need to kind of make the relaxation factor even more stringent. Or the other way of looking at it, it's maybe the Coron number we allow is just too big. So yeah, in fact, when we make the Coron number very big, it's pretty inherently known to cause instability anyhow. So there are two things we can do now. And okay, just case in point, where did we stop? Is take a look. The last time we had this instability issue at 0.8 seconds. Now we are actually going into 0.08 sorry, 0.08 seconds, but now we are actually going into 0.99 seconds, and it won't it's not showing any of these blowing up errors, which is a good thing. All right, so what can we do? Very simple. We can go to FV solution. You'll change a few things. We can actually change the equation relaxation factor, and that may help. Okay, the other option is of course to reduce the Coron number back to 10, the maximum Coron's number back to 10. Either of these should be in theory fine. So let's see, system control dict. Yeah, I'll still have the Coron number back at 100, the maximum, and I'm going to try and run pimple foam again, and let's see what happens. Okay, so just to speed things up, you can make the initial delta t a little bit higher. So I want a Coron number of, let's say, 10 initially. So we can increase this delta t by 20 times. So let's go to calculator. Okay, so we get 0.00012 times 20. So we get 0.0024. So let's go to system control dict. Let's do a 0.0024. Or you just put 2 times 10 to the power of minus 3 to be your start time. That should suffice in doing that. And let's make the right time. Let's make the right interval. Okay, instead of 10 seconds, we'll make it every 0.04. Okay, at least we have some progress saving, and we don't like completely waste all the previous calculations. Alright, so we just do pimple foam, and that should about do it. And the Coron number is about 10.675. So you can see the initial residual is 1 again. So hopefully when we go into the next iterations, you see that the residuals actually decrease. Okay, so that looks good. The residuals should be decreasing. The initial residuals should be decreasing. All right, and they are decreasing steadily. Looks good. All right. Yeah. So again, we can do another fast forward and see where we end up later on. Okay, and you know what? Maybe I'll stop for now. I'll pause this. Let's do parallel running, just to make it faster. Decompose parallel dictionary. Oh, let's do a VI system decompose parallel dictionary. We have a Scotch method of 4 subdomains. I would like to increase to 8. So let's run decompose parallel. Okay, so let's do 8 processes, and to start running we just do mpi run with the number of processes being 8, and then we do OpenFOAM with parallel, and we let it run in the background. Okay, so this is going to start, and it's going to be a lot faster. Nonetheless, it's going to take up more like computing power. Okay, if you take a look at the system monitor, I'm using way more resources. Normally one of these CPUs, it will just be one of these CPUs at about 100%. Now I have about 8, and normally temperatures will start to rise as well. Okay, this one is another Git file loading. If you want to know, I mean, this is strictly for Linux. I don't know about Windows subsystem for Linux, but you'll get about 75 degrees. I mean, on my computer is about 75 degrees maximum. So you put more CPUs to work, you'll save time, but you'll also let the thing heat up a little bit more. Okay, so it looks okay-ish for now, and it's decreasing. These residuals are decreasing, which is a good thing. And it's a lot slower than before because we kind of increased that relaxation factor. I mean, yeah, decrease the relaxation factor, excuse me. Yes, you decrease the relaxation factor so that the thing can solve a little better. So it's decreasing reasonably well. And now I guess we can just do the fast forward. Yeah, we'll do fast forward. Okay, so yes, it has worked. It looks like we are going into time equals 0.13, and you know, the theory, at least that I was trying to drive across, was as long as you put your relaxation factors lower. As long as you put your relaxation factors lower, you should be able to get the result that you want. This means to say that you should be able to get a stable solution. Yeah, you should be able to get stable solutions, and you can see we are getting a time step of delta t 0.01, which is I guess what OpenFOAM is looking for. It's a very nice time step. Yeah, it looks like it's sticking with that. Oopsie. Oops. Yes, I entered VI by mistake. Okay, so yeah, it seems to work. And let's see. I want to add some desklets for CPU usage. All right, just wanna, for convenience, CPU load. Let's see, GPU. No, don't have. Temperature. All right. Okay. Let's give this on. Oopsie. Yeah. Oh wow, this looks nice. I have 16 cores, but yeah. Let me kind of let it. Okay, that's better. A little bit bigger. All right. Wow. Let's see whether there's anything else I can do. You know, but this is what the CPU usage is like. Right, let me see. This doesn't look so nice. Don't show everything. Yeah. Okay, there we go. We can have our CPU core usage like so, which we should be able to see. Another interesting one you can do is temperature, but this one kind of shows an error, so let me just delete this. Okay, this one's not working. Alright, maybe applets. Okay, let me fast forward this part then. Okay, so yes, I have a CPU temperature indicator and CPU load indicator. You can see the temperature here is as such. Honestly, you can just go to your terminal and type sensors. You should be able to get it, but this is just, you know, convenient, so I'll leave it as this. This shows the maximum temperature. Very useful tool if you're on the Linux Mint. Pretty handy. Okay, so we have a situation where it's going into the hundreds of iterations. Okay, let's see. Yeah, it doesn't seem to be reducing. Okay. Yeah, these two guys are not they seem to be going up and down. I guess yeah. This is with a time of let's see, 0.1. Okay, 0.12, 13, 14, and 15. Okay, so this is the 0.15 time step. It's showing this oscillatory behavior again. Let's hope it kind of dies down. But from the looks of it, it does not look very promising that this will die down anytime soon. Okay, so yeah, that's okay. I have to kill the process manually. So let's do a PSA kill 18398, and that should kill the process. Yep, so it terminates everything, and we see from these processes it will reach the 0.12 time step, so the stability has increased, but it's not perfect yet. So the other thing we can do is just to decrease Courant number, decrease the max Courant number, because maybe it's not meant to run at 100 Courant number, So let's do again MPI run mp8 pimple foam, and we'll run in the background. Oopsie, sorry. No. That's bad. Okay, PSA. I forgot the parallel. Alright, so parallel N. There we go. Because if you do this, you'll probably solve one what do you call that? One of those processes at a time. Okay, so hopefully this sort of helps out. Yeah, but in general, when you do real simulations, it will really be like this process of debugging back and forth and trying to get the simulation stable. That's the reality of simulations. Um, so yeah, now the thing's running well, and OpenFOAM seems to be giving us the intended results. So yeah, it shows that you tweak around the relaxation factors and maximum Coron numbers, you will be able to get some sort of semblance of stability. So I hope this helps you, and this is actually a very key skill to have, sort of debugging your simulations. For this, I'm afraid there is no straightforward answer as to why instabilities happen, because they can happen for multiple reasons. Sometimes it's very elusive, but this is part of the debugging process and something you should get used to in doing OpenFOAM simulations. So in fact, most of the stuff I have in this repository, most of the stuff I have here, some of these simulations will not be stable. So do go and practice this skill on some of them to try and get it stable. Adjust the relaxation factors, adjust the time step, or you can adjust the maximum Coron number. Okay, so that's all I have for you this particular video. Thanks for watching. I'll see you guys next time. Bye bye.